Okay, in this video, we're going to be talking about how to solve some linear inequalities. These are the first kinds of problems that we look at in the beginning of chapter 9 in our Algebra Connections book. So this first one, 2x plus 6 is greater than x plus 7. In order to figure out what's going on with these inequalities, the first thing we're going to look for is what we call the boundary point. In order to find the boundary point, we're going to solve it just like it was any other equation. So 2x plus 6 is equal to x plus 7. We're solving it just like it's an equation, looking for the boundary point here. First thing I'm going to do is get x by itself. I just want x on one side of the equation, so I get not 2, but x plus 6 is equal to 7. Now I just want x by itself still, so I'm going to move that 6 over, and I get x is equal to the number 1. This right here is my boundary point. X is equal to 1, so I'm going to go up and over to here. And looking at the symbol that we started with, which is right here, it's not equal to, so it means I'm going to have an open circle at 1. With that open circle right there, we can move right along. Now that I have the boundary point, we need to know about shading. In order to determine where we're going to shade, we need to test a point. The easiest point to test is the number 0 to see if it works with our original inequality. So I'm going to plug 0 in for x in our original inequality. Greater than 0 plus 7. Simplify this stuff out. That goes to 0. That stuff doesn't matter anymore. 6 is bigger than 7. 6 isn't bigger than 7, so this is false. And since this is false, that means that this guy, 0, is not part of the solution set, which means all the things on this side are not part of the solution set. None of these guys get included. So we're going to have a solution set starting at a value infinitely close to 1. That's why it's an open circle. And going to the right. So we're going to shade that all to the right. Because 0 didn't work, all of the numbers on the other side have to be the ones that work. So I'll shade that guy in. Last part is to write the inequality that is being expressed by what we just graphed. And what you're going to take our x. Our boundary point was at 1. And our value for x is what's being represented by what we have shaded in here. And x is every number bigger than 1. So x is bigger than 1. So that's all there is to that guy. Next guy, moving over here. We've got another inequality guy. We're going to find the boundary point. We're going to do this one pretty quickly. We're going to solve it like it's an equation. Minus x plus 2 is greater than or equal to 0. This guy's got a negative in front of the parentheses. Be careful there. It means we're going to bring it up out of the negative space. All the signs are going to flip because it's a negative in front of the parentheses. So 3x minus x minus 2, all the signs changed, is equal to 0. We're solving it just like it's an equation here. Combine my like terms, 2x minus 2 is equal to 0. That means that 2x is equal to 2. Means that x is going to be equal to 1 when I divide both sides by 2. So I get x is equal to 1. Again, my boundary point is at 1. So I'm going to go back up to my 1. Boundary point's not always going to be at 1, but it has been for these problems. Comes out to be 1. It's pretty nice. Now we're going to test a point. Again, I'm going to use the number 0 to test the point with to see which side I'm going to shade on. 0 is really easy to work with. It's easy to multiply, easy to combine with other numbers. Works out pretty well. Greater than or equal to 0. We're going to see if this guy is a true statement or not. We're about to find out. So 3 times 0 gives me 0 minus, in the parentheses, that's going to be the number 2, greater than or equal to 0. That's a negative 2, greater than or equal to 0. Negative 2 is not bigger than 0. Negative 2 is over here on the number line, and everything to the right is bigger, which means that 0 is a bigger number than negative 2. So again, this is a false statement. And since it's false, that means we will not be shading over here. We'll be shading from this guy, which in this one is a filled-in circle because it's equal to. We'll go filled-in circle, and we'll shade to the right. 0 didn't work, so we're shading away from what didn't work. Now that we've got that all taken care of, we're just going to write our inequality. I've got x, I've got 1, and 1 is the smallest number for that x is being represented by all of this here. This is x. X is every number bigger than 1, so the alligator is going to eat x because it's bigger than 1. It can also be equal to. It was in the original part of the problem. Up here, it was equal to, so it can be equal to here as well. And that's those two examples.